When you are faced with an equation that looks like this, we're going to need to use implicit differentiation. So the implicit part of this word is what you can see in front of you. It just refers to an equation, a function that has x and y in it. Now sometimes you get a function like this and it would be really difficult, if not impossible sometimes, to actually rearrange that into the form of y equals to do differentiation in the way that you're used to. So what we're going to do instead is we're going to tackle the three different types of term that we have in this implicit differentiation situation and show you how to do it without having to do that rearranging. So let's start with the easiest part, which is the right hand side. That looks normal, so we're just going to differentiate that as normal. So 2x squared will become 4x, and the 6 just disappears when we differentiate that. So now we're going to look at the term that just has y in, so that's the 3y squared. Again, this one's fairly straightforward. You're going to differentiate it like we did the x term. The only difference is that at the end you need to multiply it by dy dx. So that's going to become 6y, and then dy dx we add after that. So then we've got the trickier one, which is the one in the middle there with the x and the y in it. So let's park the -2 because that's not going to make any difference for a minute. So I'm going to put that outside the brackets. So how are we going to tackle this? We're going to tackle it using the product rule. So u equals x, v equals y, u dashed will just be 1, and v dashed will be 1, but then we have to multiply it, remember, by dy dx. So if we put that all back together, you'll see we'll get x dy dx plus y. So what we now need to do with this is expand and rearrange and factorise so that we can just get dy dx on its own. So we've got 6y dy dx minus 2x dy dx and minus 2y equals 4x. So let's factorise out the dy dx. So that's going to give us 6y minus 2x in brackets, and let's move the 2y, so that's going to be 4x plus 2y, and then divide through by the bracket to get dy dx on its own. So that's going to be 4x plus 2y all over 6y minus 2x, and since they all divide by 2, let's simplify that to 2x plus y over 3y minus x. So let's just summarise what we've learnt there. So to do this implicit differentiation, we just tackle any x terms and numbers as normal. The y terms, we do like the x terms, but we have to add the dy dx on the end. And any xy terms, we need to use the product rule on. And then we just rearrange and factorise to get the dy dx on its own.